Okay, so this looks no different than square root, except it's cube root. But the shape is different, but the effect of A, H, and K, we do not need to write it again because it's exactly the same as for square root. So that's great. So let's look at the parent graph for cube root. We don't even know, we want to know what that kind of general shape is for the parent graph. So we're going to do y equals the cube root of x. We really haven't talked about this at all. So we're going to do y equals cube root of x. So the way you do any basic graph when you're trying to figure it out is you make a table of values. So you go like this, x, y, and you pick the easiest values that you can. So what would be an easy value for cube root? 0 is definitely in there, but I'm also going to do -8, -1, 0, 1, and 8. And that's kind of, that pattern is kind of what you want to go after, because those have cube roots. The cube root, what is the cube root of -8? Good. This is why we did the other sections. The cube root of -8, when you evaluate that, is -2, because -2 times -2 times -2 gives you -8. -1 cube root. Good. -1, 0 cube root, 0 cube root of 1, 1 cube root of 8. Nice. So we can use this to see the shape, and we'll do the domain and range. This is kind of a new function family, sort of. Okay, let's plot these. So -8, -2, 1, 2, 3, 4, 5, 6, 7, 8, -8. I'm going to make the scaling larger on my y-axis. It's fine as long as you're consistent on each axis. -1, -1 is there. 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1 is there, and 8, 2 is there. So look at this thing. There we go. There's the shape. Cube root of x, the basic parent graph, which you could remind yourself by making a little table. But let's do the domain and range, and then we'll make a connection to something that we already knew. Domain. This is such good practice of domain and range. We need this. Domain is to the right and the left. It's all the set of possible x values. All real numbers. Yes. All real numbers. It goes all the way to the right. The arrow goes all the way to the right and all the way to the left. What about up and down? Does it go up? Does it continue going up, and does it continue going down-ish? Yeah, so it's also all real numbers. So that's it. There's no limit. It doesn't like just start somewhere and go. It goes everywhere. Okay, now I just want you to make this connection, and then we'll do a kind of transformation. Recall. I want you to, this is a really important connection to make. Y equals x cubed. Do you remember the shape of y equals x cubed? If you don't, you would make a table. It goes like that. You should know it well. You should just know, oh, it's y equals x cubed. I know what that shape is. How are these related? That's my question. How is y equals x cubed related to y equals the cube root of x? That's the $1,000,000 question. Ben? It's reflected over the, there's a particular line that's reflected over. Well, it's reflected over y equals x. What are functions called that reflect over the line y equals x? Yes, inverse functions. Inverse functions undo each other. These undo. Raising to a third power and the cube root are inverse operations. They undo each other. And so the graphs are reflected over the line y equals x. Perfect. Let's do one more. We're only going to do one more little example here because it's related to what we've already been doing. Let's try g of x g of x equals the cube root of x plus 2 plus 3. And when you do your book assignment, sometimes you're just going to describe the transformation. So let's start by doing that. What happens here? Give me any. There's a couple things that are happening. It moves. Good. So I'd say translate. Is it 2 to the right though? Yeah. 2 to the left. You have to compare to the formula here. It's x minus h. So it's the opposite of what you would think. So translate 2 left and 3 up. There we go. So we kind of know ahead of time that we should use the point negative 2, 3 is going to be on there. You can tell from looking at the graph. So negative 2, 3 is a good choice in here, because if you put negative 2, the cube root of 0 is 0, plus 3 is 3. So it's a nice, easy place to start. What else should I use under the radical? So I get a perfect cube. What do I want to put there? Put a negative 1 would be nice, okay? Because negative 1 plus 2 is 1, cube root is 1, plus 3 is 4. Anything else? 6. 6 plus 2 is 8, cube root of 8, 2, plus 3 is 5, etc. So the shape, the most important point is to the left 2 and up 3. The most important point is right there, because you can actually just, if I want the general shape, I can just take this critical point here and sketch the shape, and I kind of know that it looks like that, because here's the parent graph. You shift it to the left 2 and up 3, and there's my new graph. So without even plotting specific, now I can make it better on a test or homework. I want to actually plot more specific points, but you can start to see ahead of time quickly what the new graph looks like if you understand the effect of A, H, and K. A is just 1 in this case. It doesn't do anything.